Greetings to each and everyone, especially to our advisor slash inorganic lecturer, Professor Mrs. Esperanza Del Fierro. So once again, our topic is all about acids and bases, led by Maglasang Nobime I, Tasses Paula Isabel C, Yap John Lloyd, Doc Ninya A, and unfortunately, I didn't get any pictures or picture of Gonzaga Jr., Edelyn S. Lastly, yours truly, Renan Earl Steve. Without further ado, let's start the discussion. So our learning objectives is to first define acid, base, their strength, and chemical equation. Second is to present the calculation of equilibrium, acid dissociation constant, and acid-base equilibria. Third is to discuss the pH scales. Fourth is to identify common acid-base reaction, the acidity and basicity of salt solution. Reduction of acid and bases. Acids and bases. Acids are proton donors that yield hydronium ions in water solutions, or electron pair acceptors that combine with electron pair donors or bases. While bases is a chemical species that donates electrons, accept protons, or release hydroxide ions in aqueous solution. Bases can be thought of as the chemical opposite of acids. A reaction between of acid and base is called neutralization reaction. Next, acids. Acids have long been recognized as distinctive class of compounds whose aqueous solutions exhibit the following properties, like a characteristic of sour taste. Second is changes the color of litmus from blue to red. Third, reacts with certain metals to produce gaseous H2. Fourth, reacts with bases to form a salt and water. Fifth, acidic solutions have pH less than 7 with lower pH values corresponding to increasing acidity. Common examples of acids include acetic acid in vinegar, sulfuric acids used in car batteries, and tartaric acid used in baking. So, if we think about acids mong good, so atong manunaan jud kay mostly kanang murag masakitan ta, or kanang something like corrode sa atong panit, or mahilis atong panit, or something nga kanang masakitan ta, kanang deadly kay sa atong panlawas, no. But mostly ang acids is nara sa atong duol-duol, no, especially sa atong balay or sa atong lawas jud. If you don't know, ang nagpahilis sa mga pagkaon sa atong tiyan mo ay gitawag nga hydrofluoric acids, or kanang acids na mahilis sa pagkaon kay para ma-digest og tarong sa atong stomach ang mga nutrients o mga vitamins na makuha to gikan sa atong food. Though tinuod nga kanang ang acid is na siya ay corroding effect, no, pero dili tanan mo corrode jud nga kanang di siya acid nga kanang makapasakit nato, or mostly sa mga acid ito magamit nato like vinegar o acid kanang tartaric acid nga gigamit naa sa baking soda, also kanang carbonic acid nga naa sa soft drinks, or citric acid nga naa sa mga fruits, and etc. There are three common definitions for acid. So according to Arrhenius, acid is any substance that increases the concentration of hydronium ions, or H3+, in solution. And also, according to Brasileiro, acid is any substance that can act as a proton donor. And according to Lewis, acid is any substance that accepts a pair of electrons. Next, acid strength and strong acid. The strength of an acid refers to how readily an acid will lose or donate a proton. Oftentimes in solution, a stronger acid more readily ionizes or dissociates in solution than a weaker acid. The 6 common strong acids are hydrochloric acid, or HCl, hydrobromic acid, or HBr, hydroiodic acid, or HI, sulfuric acid, or H2SO4, nitric acid, or NHO3, perchloric acid, or HClO4. Each of acids ionizes essentially 100% in solution. By definition, a strong acid is one that completely dissociates in water. In other words, 1 mole of generic strong acid, Ha, will yield 1 mole of H+, 1 mole of conjugate base, or A negative, with none of unprotonated acid Ha remaining in solution. By contrast, however, a weak acid, being less willing to donate its proton, will only partially dissociate in solution. At equilibrium, both the acid and the conjugate base will be present along with significant amount of undissociated species, or HA. The base are any substance that in water solution is slippery to touch, tastes bitter, and changes the color of indicators, like turns red litmus paper to blue, reacts with acids to form salts, and promotes certain chemical reactions, or base catalysis. Sa base, kung makanungog tag-iming ng base, kay wala tatakabaw kay it is because dili common ang base para nato, right? Name mo ta nato kanang makadungog tag word nga base is para nato wala lang, because base is not common kay sa ato ang mga panultihan, unlike sa acid makadungog muriatic acid o so minaw mo sakit yun, but base is also pareha sa acid no. Na ubang base nga harmful sa lawas, na pa ubang base nga kanang okay ra, good ra sa lawas. Like atong ubang base is edible or ubang bases kay magabit na to sa pang-hygiene. For example, soap. If makita mo, soap is a base substance no. If ma-contact siya sa water, slippery to touch siya. And if kung nakasuhay mo pag bata ninyo, accidentally nakatilaw mo sa soap, so lasa gud siyang pait gud ang lasa no. Yan. If you want to know kung ang substance ba is base, just use red litmus paper na. If it turns blue, that substance sa base, no? And pareha sa acid, gamitan ta nimo og blue litmus paper. If ang katong blue litmus paper may mo siyang red, that will be acid. So bali sa bases. Gamit kag red nga litmus paper, if blue siya, that means bases. Yeah. So and also bases reacts with acids to form salts. And same sa acid, ang acid mo react sa bases to form water and salts. There are three common definitions of bases. First is, according to Arrhenius, base is any compound that donates an hydrogen ion in solution. And according to Brusted-Lowry, bases are any compound that capable of accepting proton. According to Lewis, base are any common compound capable of donating an electron pair. In water, basic solutions will have a pH between 7 to 14. Base strength and strong bases. A strong base is converse of a strong acid, whereas an acid is considered strong if it can readily donate protons. A base is considered strong if it can readily deprotonate from other compounds. As with acids, if we often talk of basic aqueous solutions in water, and the species being deprotonated is often water itself. The general reaction looks like that. Thus, deprotonated water yields to hydroxide ions, which is no surprise. The concentration of hydroxide ions increases as pH increases. Most alkaline metal and some alkaline earth metal hydroxides are strong bases in solution. This includes sodium hydroxide or NaOH, potassium hydroxide or KOH, lithium hydroxide or LiOH, rubidium hydroxide or RbOH, cesium hydroxide or CSOH, calcium hydroxide or CaOH2, barium hydroxide or BaOH2, strontium hydroxide or SrOH2 in solution. The alkaline metal hydroxides dissociates completely in solutions. The alkaline earth metals hydroxides are less soluble but are still considered to be strong bases. Acid-base neutralization. Acid and bases react with one another to yield water and salt. For instance, hydrochloric acid added by sodium hydroxide is equal to water plus salt or sodium chloride. This reaction is called neutralization reaction. So, as you notice, wala kayo na-explain sa more about sa acid o base o sa acid strength o base. It is because I plan to explain na lang sa kinalasan because that is more important. Tumugi na unod sa akong topic karon. So, ano siya kayo, no? Kay scratch akong papel. Wala yung papel yung magamit sa kanina lang. So, let's start. So, scientific explanation day sa acids are substance that donates proton, while bases are substance that accept proton. So, sa karagdagan nga akong ipang search no, kay mo rin ako na substance. So, if damo, so care to share na lang. And so, hindi nga na pag-explain sa akong na search no. So, let's take an example sa usa ka molecule na bond no. If you can see, mo nang nagayaan nato sa high school, mga hydrogen bonding no. So, how do we know if strong ba ang acid or weak? Or strong ba ang bases or weak? So, actually, if naminaw mo sa katong slide no, so maugit to no, there are two key factors that affect the strength of an acid and also sa bases. So mo na ang polarity of molecule and strength of hydrogen bond. Though dili pa na siya sa ako lang ang own understanding, so napo siguro ilain pa nga maka-affect sa ilahang kuan sa strength no. So let's go back no. Nganong maka-apektar man ang bond sa kanang maka-apektar man sa strength sa acid no. Ano mo siya guys? So, magkakusgan ang bond magkalisod og hatag sa hydrogen kay ang bond maamong guna ang nagkupot sa hydrogen. So kung kusog kayo ang bond dire guys, maglisod siya hatag, maglisod siya buhi o so lisod kay buhian ang hydrogen. While kung weak kayo ang bond, dali kay matagak ang hydrogen no. So kung kusog kayo ang bond, strong ang bond, weak ang acid no. So mas strong ang acid if sige siya donate. So the more sige siya hatag og protons, the more siya mohatag og hydrogen, the more maga-strong ang acid no. Na siya weak bond. Since naman siya weak bond, dali kay matagak ang hydrogen dyan, no? So unlike sa bases guys, nganong ang acid raman ang proton, nganong ang acid raman makadonate, dili man ang bases, no? Because bases mangod nga substance, they have electrons, no? Daghan sila electron, though na electron ang kaning dire but kuwang, while kanina hinubra. That's why bases can only accept no og hydrogen pero di sila kahatag, while acids can only donate proton pero di sila ka-accept og proton, guys, no, because kuwang man ang ilang electron while ang base sobra ang ilang electron mo nang kuwang man ilang electron mo nang maglisod sila og kupot mo nang matagak ang hydrogen. So all in all, the weak band, the stronger the acid. The weak band, the weaker the bases. The stronger the band, the weak the acids. The stronger the band, the strong the bases. So mao rin natong dapat inumdumo, no, about sa acid and bases. So I'll pass the presentation to the next reporter, and thank you for listening. Bisag boring na akong presentation, ha. So thank you. Peace out.